Today's notes are on another way to write an equation of a line. We have slope-intercept form, we have point-slope form. The way we are going to talk about today is what is called standard form. Standard form. Starting with some vocabulary. First of all, the x-intercept. We've been talking a lot about the y-intercept. The y-intercept is right in slope-intercept form. Today, the x-intercept is where the line crosses the x-axis. The x-coordinate of the point where the line crosses the x-axis is called the x-intercept. Standard form is written ax plus by equals c. Notice x and y are on the same side of the equal sign. That's the first time that's happened, both in point-slope form and slope-intercept form. X and y are on different sides. Again, ax plus by equals c, where a, b, and c are integers. Integers meaning no decimals, no fractions. Integers can be positive or negative, so a, b, and c are allowed to be negative numbers. They should not be fractions. So we have three different ways now that we can write equations of lines. The first and the most common, slope-intercept form, we should be super familiar with. Y equals mx plus b. Y equals mx plus b is slope-intercept form, and slope-intercept form is good for graphing lines. If we have to graph a line, we would prefer that it is in slope-intercept form. The problem with slope-intercept form is I only have slope and the y-intercept in the equation, slope and the y-intercept. And a lot of times we are not given what the y-intercept is, which is why we had this secondary form, point-slope form. And it's written y minus y1 equals m times the quantity x minus x1. We've been working with that for the last couple weeks, and this is good for writing equations of lines. It's nice because we don't need the y-intercept. We can use any point in point-slope form. And the third one, standard form. Standard form is ax plus by equals c. And the problem with standard form is, notice there's no m in there. So I don't know what the slope is just by looking at standard form. It does have a b, but it's a capital B. This is not the y-intercept like this lowercase b is up here. So it's not great because it doesn't tell us the slope. It doesn't tell us the y-intercept, but it does make it easy to find the x and the y-intercepts. So the one thing it's good for is if we're given it in standard form, it is easy to graph by finding the x-intercept and the y-intercept. So taking a look at what the x and the y-intercept would represent. So we are going to be able to find an x-intercept. Suppose we solve for the x-intercept and we find that it's 5. So that's going to give me a point right here. And then we're going to solve for the y-intercept, and we'll talk about how to do that in a minute. And that'll give me a point. That'll give me this point right here. There's our y-intercept. And once I know those 2 points, all I need is 2 points to draw the graph of the line. So we're going to solve for our x-intercept, solve for our y-intercept, get those 2 points, and draw our line. So example 1 asks us to find the x-intercept of this equation. Find the x-intercept of 3x plus y equals negative 12. To find an x-intercept, we are going to plug in y equals 0. To get an x-intercept, we put in 0 for y, and then we can solve for x. To find an x-intercept, plug in 0 for y, solve for x. So again, example 1 says find the x-intercept of 3x plus y equals negative 12. So if I put in 0 for my y, it's going to say 3x plus 0 equals negative 12. And remember, adding 0 is the same thing as doing nothing. I don't need to put that plus 0 on there. So that just gives me 3x equals negative 12. Divide both sides by 3. Gives me x equals negative 4. There is our x-intercept. X equals negative 4. Notice an x-intercept is going to wind up saying x equals. Number 2, same equation, 3x plus y equals negative 12. Now it asks us to find the y-intercept. Find the y-intercept. We find a y-intercept kind of the same way we find an x-intercept, but now we are plugging in 0 for x. To find a y-intercept, we plug in 0 for x, and we solve for y. So example 2 asks us to find the y-intercept. So we're going to have 3 times, remember we're putting 0 in for the x, 3 times 0 is 0. So this whole x part goes away. I just get positive y equals negative 12. Notice there's not anything I need to do. I've already solved for y. Y equals negative 12 is our y-intercept. Y-intercept, plug in 0 for x. X-intercept, plug in 0 for y. Number 3 asks us to find both the x and the y-intercepts and graph. Find the x-intercept, find the y-intercept, and use that information to draw a graph. And the equation that's given says 4x minus 6y equals 12. Four x minus 6y equals 12. So let's start by finding the x-intercept. X-intercept, we put in 0 for y. I put in 0 for y, this whole minus 6 times y, 6 times 0 is 0. This whole minus 6y becomes 0. So I just get 4x equals 12. 4 times x equals 12, divide both sides by 4. 12 divided by 4, I get x equals 3. My x-intercept is 3. Now we find the y-intercept. To find a y-intercept, we plug in 0 for x. If I put in 0 for x, my 4x goes away. I get minus 6y equals 12. Minus 6y equals 12. Divide both sides by negative 6. I get y equals negative 2. And once I have 2 points, 2 points is enough to draw a good line in there. Question number 4. Number 4, similar problem. Find the x-intercept and the y-intercept and use that information to graph. X-intercept and y-intercept. So again, x-intercept, put in 0 for y. So the equation that's given says 2x plus y equals 9. If I put in 0 for y, I get 2x equals 9. 2x equals 9. We divide both sides by 2. And we get x equals 9 over 2. 9 over 2. Well, 8 over 2 is 4. And 9 over 2 is 1 more half than that. This is 4 1/2. So my x-intercept is 4.5 right there. Let's find our y-intercept. Y-intercept, we put in 0 for the x. If I put in 0 for x, it just says positive y equals 9. There's our y-intercept. 2, 3, 4, 5. I don't know why I'm counting. It says what they are. 7, 8, 9. And once I have 2 points, that should be enough to draw a graph. So notice sometimes our x and or our y-intercept do wind up being fractions, which sometimes isn't the best. 4.5 we can graph. If I get 13/6, we're not going to be able to really graph 2 1/6 very precisely. So finding the x and the y-intercepts, it's great, especially if they come out as integers. It's good to get the x and the y-intercept. But sometimes if it's a fraction, it's not going to turn out to be the best method. So there is one other thing we're going to do with standard form. It looks like this. It gives us an equation in standard form, 6 equals 8x minus 2y. And the directions are different this time. It does not ask us to find the x-intercept and the y-intercept. It asks us to change that equation to slope-intercept form. Rewrite into slope-intercept form. So remember, slope-intercept form says y equals mx plus b. So this is the same thing. I need to solve for y. I need to get y by itself. So the first thing we need to do to get y by itself, we need to move the x over. We're going to subtract 8x from both sides. Minus 8x on both sides. These cancel. My minus 2y comes down. On this side, I have 6 minus 8x. Those are not like terms, so I cannot combine them. You could write it as 6 minus 8x, but usually in slope-intercept form, we put the x first. So let's put the minus 8x first. Minus 8x, and then I've got positive 6, so plus 6. To get y by itself, I've got negative 2 times y. Divide both sides by negative 2. And when I divide, I need to divide everything by negative 2. Negative 8 divided by negative 2 is 4x. Positive 6 divided by negative 2 is minus 3. Y equals 4x minus 3. We have changed it to slope-intercept form. And remember, slope-intercept form, we should hopefully be pretty good at graphing. Y-intercept is negative 3. Slope is positive 4. Up 4 over 1. Up 4 over 1. All right, our last example, similar to number 5, asks us to change to slope-intercept form and then graph. So slope-intercept form is y equals, so we need to get y by itself. First thing we need to do is move our x. In this case, we are subtracting 4x. We are subtracting because I have positive 4x here. This minus sign, remember, goes with the 6y. Got minus 6y equals 12 minus 4x. Again, I'm going to write the minus 4x first. And then this is a positive 12, so plus 12. And divide both sides by negative 6. And we get y equals negative 4 divided by negative 6. That doesn't come out even. Let's just leave it as negative 4 divided by negative 6 for now. We'll take care of it in a minute. X. Positive 12 divided by negative 6. Positive divided by negative is minus. 12 divided by 6 is 2. When we go to write our slope here, negative divided by negative, we don't want to write it as negative divided by negative. Negative divided by negative we know is positive. And 4 over 6 can be reduced. What can I divide those both by? I can divide them both by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. And again, negative divided by negative is positive. X minus 2. We have now changed to slope-intercept form. Y equals 2/3 x minus 2. And based on lots of what we've been working on, hopefully we can graph that. Down 2 for y-intercept. Slope is rise over run. Up 2, right 3. And we've got our line. And notice we actually did this problem earlier. 4x minus 6y equals 12. The directions were different, but the graph should be the same. This time we changed to slope-intercept form. Notice our graph's down here. Back in number 3, I think it was. Yep. We did it by finding the x and the y-intercepts. We did it differently, but we wound up with exactly the same graph. So either way you do it should give you the same graph. Sometimes it's easier to find the x and the y-intercepts, like here. Those are integers, so nice and easy. Sometimes it's easier to change to slope-intercept form. Usually the directions will tell you how to do it. If it just says graph, you could do it either way. That's it for today's notes. Reach out to me or your instructor if you're having questions.